Lesson 2.1 Factors and Multiples. This is a new chapter. We'll talk about number theory. Factors are two or more numbers that are being multiplied to get another number, which is the product. The product is always divisible by its factors. The example, 4 times 5 is equal to 20. Both 4 and 5 are factors of 20. So 20 is divisible by both 4 and 5. 20 divided by 4 equals 5, and 20 divided by 5 equals 4. A number is divisible by another number if it can be divided without remainder. Without doing the actual division, we can use the divisibility rules or divisibility tests to identify the factors of a given number. This is done by examining the digits of the number. The divisibility rule by 2 to 12. Let's get started. Divisibility rules. Divisibility rule by 2. A number is divisible by 2 if it's an even number. An even number ends with the digit 0, 2, 4, 6, or 8. For example, number uno. The number 28,864 is divisible by 2. Look at the line. Its last digit is 4, so it's the even number. The number 10,685,730 is divisible by 2 because its last digit is 0. It is an even number too. Divisibility rule by 3. A number is divisible by 3 if the sum of its digit is divisible by 3. The number 33,285 is divisible by 3 because the sum of its digit is 21, which is also divisible by 3. We need to add these digits. 3 plus 3 is 9, plus 2 is 11, plus 8 is 19. Wait, no. 19. Plus 5 is 24. But this 21 is not doing enough. But it's okay. We will try this one for later. But it will be right is 3 plus 3 it's 6. 6 plus 2 is 8. 8 plus 8 is 16. Plus 5 is 21. So yes, because you need to add these 5 add-ins. Let's try another one. The number 351,243 is divisible by 3 because the sum of its digit is 18, which is also divisible by 3. So we need to add these 6 add-ins. 3 plus 5 is 8. 8 plus 1 is 9. 9 plus 2 is 11. 11 plus 4 is 15. 15 plus 3 is 18. But I messed up for the multiply. It's not multiply yet. We need to add. Okay? Divisible by 4. A number is divisible by 4 if its last 2 digits from a number that is divisible by 4 or if the last 2 digits are both zeros. Let's try another sample. The number 30,116 is divisible by 4 because its last 2 digits, which form 16, is divisible by 4. Because there's 16. 16 divided by 4 is 4. So we need to this is divisible by 4. The number 413,600 is divisible by 2. But it's divisible by 4 because its last two digits are both zeros. But I messed up when we get to divisible by 2. But it's okay. It's still divisible by 2. Divisibility rule by 5. A number is divisible by 5. It is the last digit is either 0 or 5. Let's try another example. The number 276,245 is divisible by 5 because its last digit is 5. Next is the number 625,523,470 is divisible by 5 because its last digit is 0. Divisibility rule by 6. A number is divisible by 6 if it is divisible by both 2 and 3. This means that the number should be even and the sum of its digit must be divisible by 3. For example, the number 5,130 is divisible by 6 because it is even number and the sum of the digits is 9 because 5 plus 1 plus 3. 5 plus 1 plus 3 only because there were 3 addends because I know this 9, which is also divisible by 3 because there were even numbers like 0, 2, 4, 6, or 8. And this is sum of 3. The sum is the digit is 9. The number 231,642 is divisible by 6 because it's even number. Because the even number is 2. And the sum of the digit is 18, which is also divisible by 3. It looks like 2, and you need to sum 2 plus 3 is 5, 5 plus 1 is 6, 6 plus 6 it's 12, 12 plus 4 is 16, 16 plus 2 is 18. Yes, you need to add the 6 addends. Divisibility rule by 7. To test the divisibility rule by 7, takes the last digit of the number, double it, and subtract it from the remaining digits. Repeat the process until the result is either 0 or 7. The number 440 and then 441 is divisible by 7. 440, it will be 44 minus 2 times 1. 2 times 1 is 2, so 42. 4 minus 2 times 2, so 4 minus 4 is 0. It will be also divisible by 7 because it will either 0 or 7. The number 2,884 is divisible by 7. Just start with this, the biggest number. 2,884 is 288. Nope, it will be 288 minus 2 times 4, that will be 8. Now we vary out 280. Now it still is 28. Now we need to multiply 2 times 8 minus 2, and also be the 16 times minus 2, that will be 40. And also we can use 2 times 4. Now we need to subtract by 1, so it's 8 minus 1, so it will be 7. It is 7 because it's 7. It will be the divisibility rule by 7. It's really important. Like this, you can use the parentheses. Divisibility rule by 8. A number is divisible by 8 if its last 3 digits from a number that is divisible by 8, or if the last digits are all zeros. The number 28,808 is divisible by 8 because its last 3 digits, which from 808 is divisible by 8 because the 8's over here and 8's right this way. The number 325,000 is divisible by 8 because its last 3 digits are all 0. Divisibility rule by 9. A number is divisible by 9 if the sum of its digit is divisible by 9. The number 27,639 is divisible by 9 because the sum of its digit is 27, which is also divisible by 9 because 2 plus 7 is 9, 9 plus 6 is 15, 15 plus 3 is 18, 18 plus 9 is 27. So it's also the divisible by 9. The number 301,203 is divisible by 9 because the sum of its digit is 9, which is also divisible by 9 because it's used 9, 3 plus 1 is 4, 4 plus 2 is 6, 6 plus 3 is 9, so it also will be it. There are three more about divisibility rule. Let's do it in the divisibility rule by 10. A number is divisible by 10 if its last digit is 0. The number 279,580 is divisible by 10 because its last digit is 0. The number 72,358,640 is divisible by 10 because its last digit is 0. Divisibility rule by 11. To test the divisibility rule by 11, subtract the sum of the alternating digit. If its result is 0 or 11, the number is divisible by 11. Like for example, the number 2,783 is divisible by 11. Now we need to subtract 2 plus 8 and 7 plus 3. So 10 minus 7 minus 10, it will be 0. That will be divisible by 11. The number 54,439 is divisible by 11. 5 plus 4 plus 9 minus 4 plus 3. This one's 18 on the left side and 7 on the right side, so that's 11. So that will be the divisible by 11. Let's try the last one. Divisibility rule of 12. A number is divisible by 12 if it is divisible by both 3 and 4. It means that the last 2 digits from the number must be divisible by 4 and the sum of all its digits must be divisible by 3. Like for example, the number 3,312 is divisible by 12. Because its last 2 digits will be 12, more a number is divisible by 4, and the sum of all the digits is divisible by 3. So 3 plus 3 is 9, 9 plus 1 is 10, 10 plus 2 is 12. It's also divisible by 3. It will be divisible by 12. Let's try the last one. The 350,244 is divisible by 12 because its last 2 digits is 44. For a number divisible by 4, because it's 44, it will be 11. And the sum of all its digits is divisible by 3. 3 plus 5 is 8, 8 plus 2 is 10, 10 plus 4 is 14, and plus 4 is 18. So this will be the divisible by 3, not 4. But because there are 2 digits, there are last 2 digits, yes. Next is multiples. Multiples are the numbers we get after multiplying a number by counting numbers. Each number has the infinite number of multiples. Factors and multiples are related to each other. They both involve multiplication. The product of 2 factors is the multiple of each of the factors. You can also use skip counting to get some of the multiples of a number. Like for example, what are the multiples of 8? 1 times 8 is 8, 2 times 8 is 16, 3 times 8 is 24, 4 times 8 is 32, 5 times 8 is 40, and so on. That will be n times 8 is 8n. So the multiples of 8 are 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, and so on. We need to keep going and keep going. Let's do the last one. What are the multiples of 9? By skip counting by 9s, like 9, 8, 27, 36, 45, 51, 63, 72, 81, and 90, and so on. So, the multiples of 9 are 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, and so on. That will be the factors that will be a divisibility rule by 12. Divisibility rule, and the multiples we did get any skip countings, and you can use the counting numbers and the line number line you can use from. Skill boosters is really fun. On the pages 35 to 36. You can buy this book already. You can buy already. You need to read and answer the following questions. You don't have any book, just watch the YouTube and search me, the teacher Bimio. So we know that the factors are the divisibility rule, and the multiples are each of them is they use skip counting times. In our next lesson 2.2, we'll talk about the greatest common factors. I hope you have a really wonderful day, and I hope you join me, and we'll see you on the next video. Bye!